Today we shall discuss about the stratigraphy of the Singhum Craton. So let us begin. We all have discussed in the previous classes that the cratons, they are essentially Archean in age. So even the Singhum Craton, it has Archean age of emplacement. Age of emplacement. And its formations, they range up till Paleoproterozoic. So they have formations ranging till Paleoproterozoic. So we can say that the rock formations in the Singhum Craton, they range from Archean to Paleoproterozoic. The major states in India in which the Singhum rocks they are exposed, they include Jharkhand, Odisha, and then in some parts of the eastern Indian Shield. Eastern Indian Shield. Now, Singhbhum Craton is important in the sense that it lies in the vicinity of two Proterozoic mobile belts. So, I'll draw the diagram for you, but first of all, you should remember this that the Singhbhum Craton, it has the Satpura mobile belt in east, north, and northwest directions, while the Eastern Ghat mobile belt, it is in the south. So if I try to draw a schematic diagram, so this will be the this will be the Satpura mobile belt, and this shall be the Eastern Ghat mobile belt, and in between these lies the Singhum Craton. Singhum Craton. The Singhum Craton, it is it lies close to the Bastar Craton. So if we look at the peninsular part on the of the Indian Shield and on the eastern coast, eastern side, no sorry, not eastern coast, but on the eastern side, then this is the Satpura mobile belt. This is the Eastern Ghat mobile belt. This is the Singhum Craton, and somewhere where over here, this is the Bastar Craton, and the Bastar Craton and Singhum Craton, they are separated from each other. The Bastar Craton and Singhum Craton, they are separated from each other by the Mahanadi Graben. Mahanadi Graben. The the Singhum Craton, it comprises of Paleoarchean and Mesoarchean tonalitic, granodioritic, granite, and gneisses, and has abundant occurrences of banded iron formation closely associated with basic volcanics and ultra basic intrusives. So, the major rock types in the Singhum Craton, they are tonalitic and granodioritic gneisses and granodioritic gneisses along with gneisses and granites. Apart from it, there are banded iron formation. Then there is lot of basic volcanics. Apart from this, there is lot of ultra basic intrusives. Ultra basic intrusives. Now, these rocks have also undergone regional metamorphism, and the grade of metamorphism or the facies of metamorphism to which the metamorphism has occurred is amphibolite facies. So these rocks metamorphosed up to metamorphosed up to amphibolite facies. Amphibolite facies. Now it is believed that the Singhum Craton it is it has evolved due to multiple phases of compressive deformation related to Singhbhum orogeny. Singhbhum orogeny. And we all know that the Singhbhum Craton it provides the largest deposits of iron ore and chromite. So apart from it, the Singhbhum region is rich in several metalliferous ores. Now, in the previous lecture, also I had mentioned about the Singhbhum shear zone. So the northern tectonic boundary of Singhum Craton is marked by the Singhum shear zone. Singhum shear zone, which is also commonly referred to as SSZ. And it is also known as, very importantly, it is also known as copper thrust belt. Lot of copper deposits are here. And as I had previously mentioned, iron ore and chromite deposits are here. The Singhum shear zone is also referred to as the copper thrust belt. Copper belt thrust, not copper thrust belt, copper belt thrust. It's kind of thrust fault over here. The Singhum shear zone it separates the Singhum Craton from the Chota Nagpur gneiss terrain. Remember this, that separates Singhum Craton from Chota Nagpur. Chota Nagpur gneissic terrain. Okay. The origin of Singhum shear zone is also sometimes believed that the Singhum shear zone it originated as a normal fault, along which there was a subsidence of the northern block, and it gave rise to the Singhum basin. Later, the reversal of sense of movement made it a shear zone, which was later called as Singhum shear zone, and it became a zone of immense magmatism, metasomatism, and mineralization. This makes the Singhum region very important for uh, the ore deposits of India. Now, northern boundary was marked by these Singhum shear zone, also referred to as the copper belt thrust, while the southern boundary it is marked by Sukinda thrust. And all of us are aware that the Sukinda, it is uh, a huge deposit of the chromitors, Sukinda chromites. Okay. So you can see that the northern tectonic boundary has copper deposits, southern tectonic boundary has a chromite deposits. Okay, so based on this general information, let us try to draw the map of the Singhbhum Craton. Now, if you remember, I had told you about the uh, Deccan proto-continent in the first class, that we have the Indian shield can be divided into the northern block and southern block. The southern block is also referred to as the Deccan proto-continent. So I had already told you that the uh, out of the five major cratons, three are in the southern block. That is the Dharwar Craton, Bastar Craton, and the Singhbhum Craton. While in the northern block, there are two important cratons, the Bundelkhand Craton and the Aravali Craton. So if we now recall all those things, so we know that the Singhbhum Craton, along with Dharwar and Bastar Craton, is a part of the Deccan protocontinent. So if I try to draw the southern part of Indian shield, then this is the central Indian tectonic zone, and this portion over here, this is the Singhum Craton. Then we have the Bastar Craton, and then we have the Dharwar Craton. Okay, so this is a part of Deccan protocontinent. Now, age of Singhum Craton is given to be 3.4 to 2.5 billion years, while this is the age of Singhum Craton, while the age of Singhum Shear Zone or Singhum Mobile Belt, it is younger than younger to 2.5 billion years. This you should keep in mind. Now, if we trying to draw the map, and this is the north, so sorry, in the beginning I had told you that the Singhum Craton, it lies in the vicinity of two mobile belts. So if this is the north direction over here, then let us draw now the first the northern boundary. The part of the Satpura mobile belt which binds the Singhum Craton close to this region, it is called as the Singhum mobile belt. So we are getting the northern boundary over here, and the northern tectonic boundary of the Singhum Craton, it is marked by a shear zone which we can refer to as Singhum shear zone. So this portion, it is the Singhum shear zone, while this entire portion, it is the Singhum mobile belt. Singhum mobile belt. Then there is a, so we are moving from north towards south now. And of course, let us now draw also the southernmost tectonic boundary, which will be this. And I had mentioned that the southern tectonic boundary, it is marked by the Sukinda thrust. So this is the Sukindra thrust. Now, in this, the and also let us write the stratigraphic formations on one side so that we can mark it over here. The oldest rock formation in the Singhbhum region, the Singhbhum Craton, is the older metamorphic group, which is just uh, s- some little portion of it is remaining these at the present time. OMG is followed by older metamorphic tonalite gneiss. So these two are the oldest rocks in the Singhbhum Craton region with an age of emplacement as 3.7 billion years. Okay. And this OMTG, it is the oldest metamorphic sedimentary, or not metamorphic, these are oldest meta sedimentaries in the Singhbhum. So this position of OMG and OMTG may be drawn like this. Okay. So these two may be referred to as OMG, OMTG. The next rock formation which comes here is the Singhum granite. Now there are three phases of emplacement of Singhum granite. So the phase 1 and 2, Singhum granite. Age of Singhum granite over here. So I'll write 1 and 2. This is first, and we'll discuss this in detail later. Age is 3.3 billion years. This Singhbhum granite is a type of TTG. You remember TTG from the Dharwar class? So now this Singhbhum granite is a huge granitic pluton this way. So this portion of the pluton which is exposed in the central part of the Singhbhum Craton, it can be referred to as Singhbhum granite. Singhbhum granite. Further, the after the TTG, we get the greenstone sequences. Remember, we had TTG and greenstones together in the previous class of the Harvars we had discussed. So here now, after this, we get a greenstone sequence which is called as the iron ore group. The iron ore group, these are greenstone sequences. Greenstone sequences. The iron ore group, it has three very important deposits which are exposed over there, and you must be knowing the name. Daitari Nosahi, Daitari Nosahi, then Noamundi Koira, Noamundi Koira, and then Goru Mesani Badam Pahad. Guru Maisani and Badam Pahad. These are very important iron ore deposits. And this is then further overlain by the third phase of Singhum granite. So again, a TTG. So we can see here that the fringes of those green stones are, associated with the TTGs. Now, where are these three belts located? The iron ore group, this is scattered. It's not in one location in the Singhum Craton. So the Daitari Nosahi belt, that is the iron ore group, is somewhere in the southern portion near the Sukinda thrust. So this is Daitari Nosahi, and you should remember that it is a part of the iron ore group IOG. Then we have one of the iron ore belt, that is Goru Mausani Badam Pahad, exposed somewhere here in the eastern portion. This is the Goru Mahsani Badam Pahad. Again, iron ore group IOG. And the third one, it's on the western portion. It's exposed like this. This is the Noa Mundi Koira. Noa Mundi Koira. It's again iron ore group. Okay. All right. So I hope you are following here till now. The OMG, this older metamorphic group, is also referred to as the Champua group. So this location Champua, remember this Champua. Okay. Then after the Singhum granite phase 3 comes the Singhbhum group. Singhbhum group, which has age of emplacement as 2.3 billion years, and it is followed by the Dhanjori group. Dhanjori. So if we see this, then other rocks which are exposed in this region, they include the Nilgiri granite over here. This is the Nilgiri granite. Then those of you who are from Orissa must have heard the name of Simlipal Tiger Reserve. The Simlipal is a type of volcanic vent. So Simlipal volcanics, they are exposed over here. So this is the Simlipal volcanics. Apart from this, then just now we had seen after the uh, you know Singhum granite phase the Singhum group, and then the Dhanjoris. So the Dhanjori is again uh, a lava flow with quartzite and conglomerates. So the Dhanjori is exposed somewhere here. Hanjori lava flows. Then there is a uh, lava flow which is exposed north of the Singh shear zone. This one. This is called known as Dalma lava or Dalma volcanics. Volcanics. So this gives us more or less a rough idea of the Singhum Craton. Okay. So the Singhum Craton, it consists of the older metamorphic group followed by the older metamorphic tonalite group or tonalite gneisses. Then there are two phases of emplacement of Singhum granite, and then followed by the iron ore group. then the third phase of Singhum granite, and then the Singhum group. Okay. All right. Now let us see the different types of the igneous rocks which are present over in the Singhum Craton. So always draw it like an eye. If you draw it like this, you will get full marks in your UPSC examination, GSI and all. So this over here, it is the Singhum Mobile Belt, the Singhum Mobile Belt. So we have a large body which is called as the Singhum Granite central portion. You all remember this? It is flanked on the eastern part by two volcanic flows, the Hanjori flow and the Similipal. Okay, Hanjori and Similipal. Then, south of these two flows, there is an important rock body called as Mayurbhanj granite. Mayurbhanj granite. And in the previous slide also I had showed about the Nilgiri granites. Nilgiri granite. Then within the Singhbhum granite, it kind of covers the OMG and OMTG as I had mentioned in the previous slide. So the iron ore group, is a kind of very narrow body which is exposed some at some places. Iron ore group is over here. Then some part of iron ore group are scattered. So this and this, they both are the iron ore group. And this large body, as I had mentioned, is the Singhbhum granite. All right. Then over here, these are the Kolhan quartzite. Kolhan. On the western side, there is another lava flow known as Jagannathpur lava. Jagannathpur lava. Western portion has another important rock emplacement known as Bonai granite. Okay. So if we try to mark a boundary all along this region, then we can say that there are several of these igneous bodies which are exposed surrounding this central Singhbhum granite. Now, in this, the OMG and OMTG, they have this age of 3.7 billion years, followed by Singhum granite phase 1 and 2, then iron ore group, and then again Singhum granite phase 3. Then in the previous slide, I had mentioned about the Dhanjoris. Now here I have told you about Jagannathpur and Kolan. So the Hanjori, Kolhan, and Jagannathpur, which have an age of almost 2.3 billion years, they are platform sequences. They are platform sequences and thus they are undeformed. So the Hanjori, Kolhan, and Jagannathpur, they all three, they are the platform sequences. Platformer sediments sequences, and they are undeformed. Okay. All right. Let us see another diagram. To be more precise now, the as I had previously mentioned that this Singhum mobile belt, the northern part of the Singhum Craton, it separates the Singhum Craton from the Chota Nagpur Gneissic complex. So let us write it over here C G C. It is the Chota Nagpur Gneiss complex. Let me draw some symbols for you so that these are the a separate rock body. Now, the northern portion of the Singhum mobile belt is also known as Tamar Por Pahar Shear Zone, known as Tamar Porpahar. Tamar Por Pahar Shear Zone, also referred to as TPSZ. So, what is TPSZ? It marks the northern margin of Singhum mobile belt. Northern margin of Singhum mobile belt, and the Tamar Porpahar shear zone is also referred to as South Purulia shear zone. Now that GSI is asking, it is conducting prelims also. So you may be asked, what is the different name for Tamar Porpahar shear zone? If at all this question is asked, then answer will be South Purulia shear zone and all. Now the northern tectonic boundary of the Singhum Craton is the Singhum Shear Zone, as previously mentioned. So this is Singhum Shear Zone. In between these two, now importantly, Singhum Shear Zone, which is also known as Copper Belt Thrust, it is the southern margin of the Singhum Mobile Belt. So it's a very important thing that the northern margin of Singhum Mobile Belt is the Tamar Purpahar Shear Zone, while the southern margin is the Singhum Shear Zone. Southern margin of Singhum mobile belt. Should remember this that the northern margin is marked by the Tamar Pahad, while the southern margin is marked by the Singhum mobile belt. And in this comes the Dalma Volcanics. If you see the previous map drawn on this previous slide, so this is the Dalma Volcanics. The Dalma Volcanics is also sometimes referred to as Dalma ophiolites. So if it is an ophiolite suit, it means that it is an old ocean crust. So this old ocean crust has been derived from which ocean? The Dalma ophiolites, they represent old ocean crust of the Satpura Sea. Now we know that today where there is the Satpura Mobile Belt region, once used to lie the Satpura Sea. So this southern margin of the Singhum mobile belt SSZ, it also has copper mineralization. Copper mineralization. So if we now look at the stratigraphic successions in the Singhum mobile belt. So previously, all these, the from OMG to this Singhum granite, from here to here, this is the Singhum Craton. While now we are going to write the Singhbhum mobile belt succession. So we start from the Singhbhum shear zone. It is followed by the Singhbhum group. Singhbhum group. The Singhbhum group, it has on the base, it is the basal conglomerate. Then Chaibasa formation, Chaibasa, followed by the Dalbhum formation. These two, they are major rock types as schists and phyllite. Phyllite. Then, sorry, after this comes the Dalma Volcanics. Dalma Volcanics. And then it is followed by the Chandil group. Chandil group. So this Chandil group, it has large amount of chert, volcanic deposits, cyanides, nepheline cyanide, etc. And then it is on the topmost is the Tapas Porpahar shear zone. So this entire succession, it is the Singhum mobile belt. Okay. So I hope it is clear. Now we had mentioned about the Satpura Sea and the uh, ophiolite suit and all. So let us have a look at the cross section of the Singhbhum Craton and the fringes Singhbhum mobile belt and all, so that you can understand. So we go from the south towards the north, and we know that the southern portion, it has it is bordered by the southern portion is bordered by the Eastern Ghat mobile belt. So we draw it like this. So this is the southern portion. We go towards the northern portion over here. We go towards north. All right. So we all know that in the southern portion lies the Eastern Ghat mobile belt. Just hold on, guys. Let me make the screen proper for you so that there is no problem writing it. Yeah, okay. So on the southern portion, there is the Eastern Ghat mobile belt. And we know that this Eastern Ghat mobile belt, it is it has this Sukinda thrust over here. The southernmost boundary is marked by the Sukinda thrust. All right. So if we go from now south towards north, then there is the iron ore group over here, followed by the this portion over here, it is a Singhum Craton. On the top, these are the Dhanjori, Simli, Pal, and Kolan, which are the platformer sequences. Hanjori, Simlipal, and Colon. And again over here, this is the iron ore group. Then comes the northern tectonic boundary of the Singhbhum Craton, which is the Singhbhum Shear Zone. So between these two, it is the Singhbhum Craton. Then, if we now move towards the Singhbhum Mobile Belt towards the north, then first of all, we have the pelitic rocks over here. And these rocks over here, they are the Dalma Volcanics. Then these are the volcanic rocks exposed. And then we have the northernmost boundary of the Singhbhum Mobile Belt, known as the Tapas Porpahar Shear Zone. And then it is separated from the, as previously mentioned, the Chota Nagpur Gneiss Complex. All right. So this portion to this portion, it is the Singhbhum Mobile Belt, while here to here, it is the Singhbhum Craton. Okay. So in between the Singhbhum Craton and the Chota Nagpur Gneiss Complex, the situation was somewhat like this. So this portion over here is the Singhbhum Craton, and this is the Chota Nagpur Gneiss Complex. Now, this basin was the Singhbhum Basin. Singhbhum Basin, which had an age of almost 2.3 billion years. So this was the ocean floor. Okay. This was the oceanic crust. This oceanic crust was overlain by the sediments. Now what happened was that there was the subduction that occurred. So this is the subduction zone. So this subduction of the basin, it caused the ocean floor volcanic to compress, and then they gave rise to the Dalma volcanics. How did this happen? Let us see. When this subduction occurred, then the situation might have been like this. So this was the Singhum Craton. Then Chota Nagpur Gneiss Complex over here. This was the Singhum Group. This was the Chandil Group. And this shear zone over here, it led to the formation of what we today know as the Dalma ophiolites. Okay, so this is how the Dalma ophiolites had formed. So I guess you understood the tectonic evolution of the entire Singhum Craton along with the Singhum mobile belt. Now, if we discuss the lithostratigraphy of the Singhum Craton province, then six major lithotectonic units are recognizable. When we say uh, Singhum Craton province, it means that we are talking specifically about the Archean successions. So, all right. So, see this. Now, when we are talking about the litho units of the Singhum Craton, as I told you, that these are typically the Archean portion. So, if we look at the Archean part, then we have on in the base at the lowermost unit is the OMG or older metamorphic group, which is also known as the Champua group because of its location in the Champua area. It is followed by the or overlay, not followed by, it is overlain by Saraikela gneiss, also referred to as older metamorphic tonalite gneiss. Then there is the third one, which is known as the Besoi granite, also referred to as Singhbhum granite type A, which is phase 1 and phase 2. Then the Besoi granite is unconformably overlain by the iron ore group. And then next phase of granitic emplacement was there, which is known as Singhum granite type B, also known as Bonai granite. So you should remember this, that the Singhum granite type A is the Besoi granite, while Singhum granite type B is the Bonai granite. Bonai granite. Then Bonai granite is unconformably overlain by the Dargin group. So over here we have this major Archean Craton formations exposed. So this is the Singhum Craton or the Archean portion of it. The Neo-Archean to Paleoproterozoic, it includes, as I had previously told you, the Singhum group, Hanjori group, and the Chandil group, and followed by the Kolan group. So we will see how they have been exposed. So if we talk about the typical Archean litho units only, then there are six major litho units which are recognizable. Five of these, they exhibit amphibolite facies metamorphism. The top one, the Singhum group, it is the one which is free from deformation and free from metamorphism, and they are unmetamorphosed sequences. Now the five lower units, from OMG to the Singhum granite, they have undergone multiple phases of deformation during the Singhum orogeny, and thus we now know that the Champua group, it is the oldest group. Champua group is the oldest group, while the Singhum granite type B, which is the phase 3, it forms the larger part of the granitic batholith complex. Okay. So the Champua group, it is the oldest lithostratigraphic unit of the Singhum Craton. It lies south of the Singhbhum shear zone. It is also referred to as older metamorphic group and consists of hornblende schist with quartzite, quartz mica schist, metamorphosed pelites, sandstones associated with ferromagnesian lithologies in the Champua region. And it is transformed by the amphibolite facies metamorphism. Age has been given as 3.6 to 3.3 billion years. Oh, it is overlain by the Saraikela gneisses, and Saraikela gneisses are the TTG. So it is intrusion, is also referred to as the older metamorphic tonalite gneisses. Sorry, it is not TTG, it is OMTG. It is OMTG. And these OMTG has been derived from the partial melting of OMG, the older metamorphic group. So this partial melting of the older metamorphic group, it led to the evolution of tonalites in the rock records. Next, it comes the Singhum granite type A or phase 1 and 2, which is also referred to as the Besoy granite. It is a large basaltic complex with a large number of plutons and divided into Singhum granite type A and type B. So the type A, which is phase 1 and 2, it is the Besoy granite. They have xenoliths of rocks of Champua group and Saraikela gneisses all over the granite. So if you remember, I had shown you in the first map that I had drawn. If you see here, in this, you are finding that in this large batholith, there is some portion of OMG and OMTG. So this OMG and OMTG over here, they are exposed as xenoliths, foreign bodies in that larger granites. They are biotite granodiorite grading to tronzemite. Age has been given as 3.3 to 3.2 billion years. Overlying the Besoy granite, separated by an unconformity, is the iron ore group. It is mildly metamorphosed and then has predominantly ferruginous sediments associated with basic volcanics. I had previously told you that it has three important, the belts which are exposed: the Daitari Nausahi, Nuwa Mundi Koira, and Goru Maisani Badam Pahad. And here it is all banded iron formation, which is closely associated with lavas and tuffs. Age has been given as 3.15 billion years. Okay. So if you see in this diagram, the stratigraphic succession of iron ore group in the iron ore belts, in the Daitari basin, we have basal quartzites interlayered with banded cherty quartzites and then black chert, followed by or overlain by banded magnetite, hematite, jasper within thin volcanic tuff and enriched iron ore. In the Jamda Koira, Noa Mundi Koira, we have at the base is OMG, unconformably overlain by quartzite, then lower tuff and graybacks, banded iron formation, manganese bearing shale, upper tuff and volcanics. While in the Goru Maisani Badam Pahad region, we have this OMG exposed and then OMG is overlain unconformably by basal conglomerate, followed by quartzite, fuchsite, then banded magnetite, banded cherty quartzite, banded magnetite. So we can see here a lot of banded iron formations are exposed in this region. The next is the Singhum granite type B, which is the larger part of the Singhum granite. So it is the third phase of emplacement of this batholith. It makes the larger part of the batholith complex. It represents the third phase of magmatic emplacement, and it has intruded iron ore group at some places. The the rock type over here is biotite granodiorite to adamelite, biotite tronzomite, and leucogranite. Age has been given as 3.1 to 3.04 million years or billion years. It is overlain by the Darjan group, which lies to the west of the Singhbhum batholith complex or Singhbhum granite. Slightly metamorphosed and undeformed sedimentary rocks. They are the platformal sequences. cross-bedded and ripple-marked conglomeratic sandstone, arcosic sandstone, shales, carbonaceous phyllites, and dolomitic limestones are there. It is overlain by the Tamper Kola granite, which intrudes the Darjeeling group, alkali feldspar dominated granite, and it marks the last thermal event of the Neo-Archean in the eastern part of Indian Shield. It's very, very important that the Tamper Kola granite, it marks the last thermal event of the Neo-Archean in the eastern part of Indian Shield. So if a multiple choice question is asked, which of the following rock types or the stratigraphic horizons they mark the last thermal event of eastern Indian Shield during the Neo-Archean, answer will be the Tamper-Kola granite. So, evolution of the Singhbhum Craton, the Archean lithology of the Singhbhum Craton, it has been, studied in great detail, and it has been given as that during Archean there used to be a proto-continent which uh, you know which was present, and then due to the consistent mantle plume activities, this got stretched. Due to this tensional stretching of this protocontinent, a depression was created in which the sediments which got deposited in the basin got metamorphosed to the amphibolite facies, and that formed the Champua group or the older metamorphic group. The partial melting of this protocontinent and this, Champua group, it led to the generation of the tonalitic magma. And this tonalitic magma, it intruded the OMG, which was later known as Saraikela granite, and then which is also called as older metamorphic tonalite gneisses. So we now know that the OMTG has been derived from the partial melting of the Champua group or OMG itself. So it is the emplacement of tonalitic magma which contributed to the kinematic growth of the OMTG. Then the granitic magmatism it continued, and thus we got the emplacement of the Singhum granite type A, which was the first and second phase of the magmatism, which was referred to as the Besoy granite. So the Besoy granite it overlies the OMG and OMTG. Then the thermal perturbations in the subcrustal level of the elongated microcontinent, they led to the formation of this, the deposition of the ferruginous and siliceous sediments, and emplacement of banded iron formation in basic lavas, and intrusion of gabbro and related ultra basic magmas. So all these rock types they led to the formation of the iron ore group. This deposition of these ferruginous and siliceous sediments, it was in a shallow water basin which was north northeast, south southwest oriented. The deformation it continued, metamorphism continued, and the deformed iron ore group it got it changed to a synclinore. During that process, there was sinking of sialic crust, caused differential melting, and thus that melting led to the emplacement of the next phase of uh, granitic magmatism, which was called as the Bonai granite or the type B granite or the third phase of granitic basalith formation. Now, in the western part of the Singhbhum basin, there was subsidence, and the shallow basin of the Darjin group it got little metamorphosed and undeformed sediments. After the deposition of the Darjin group, the last thermal event of the Neo-Archean in the eastern part of Indian Shield occurred, which was represented by the Tamper Kola granite. Okay, so the Tamper Kola granite emplacement, it is an important event in the Indian Shield. The base of the Paleoproterozoic of Singhum Craton it is marked by the evolution of Singhbhum mobile belt. So we can understand that the formation of the Singhbhum Craton ended by the start of evolution of the Singhbhum mobile belt. Now, the evolution of Singhbhum mobile belt has been attributed to several factors, and the uh, Singhbhum mobile belt, it is thought of having evolved due to the intracratonic northward subduction of continental plate with Singhbhum granite along the Singhbhum shear zone. Then it is thought that the collision of continental blocks represented by Singhbhum granite and Chota Nagpur gneisses, it resulted in abduction along the Dalma volcanics. Then the southward subduction of Chota Nagpur plate and the back arc zone evolving in the Singhbhum mobile belt. So the rock successions which lie to the north of Singhbhum shear zone, they extend in a series of east-west folds, and this succession has been named as the Singhbhum group. The Singhbhum group, so let us see if that is there. Yeah, the Singhbhum group, it is divided into lower Chaibasa formation and the upper Dalbum formation. The Chaibasa formation, it consists of high-grade mica schist, hornblende schist, and quartz granulites, while the Dalbum formation, it consists of phyllites and banded quartzites, and it has a lower grade of metamorphism than Chaibasa formation. Then comes the Hanjori group. So the Hanjori group, it consists of basal conglomerate, arkose, quartzite, and extensive lava flows. It sits unconformably over the Singhum granitoid complex, and it is considered to be the first volcano sedimentary sequence deposited after intrusion of Singhum granite type B. The terrestrial fluvial deposits which are overlain by mafic, ultramafic volcanics and volcaniclastics. The age is suggested to be late Archean to early Paleoproterozoic. So we can say that its age is around Neo-Archean to Paleoproterozoic, around 2.5 to 2.4 billion years. Now it has the uh, Dalma Volcanics, which is conformably overlying the Dalbum Formation, while Simlipal Basin in this region is relatively undeformed and lies in the eastern part of Singhum Craton. The volcano sedimentary sequences they sit unconformably on the top of iron ore group and Singhum granite type B, and it is also intruded by the Mayurbhanj granite and gabbro. This is the Mayurbhanj granite. And at the top is the Kolan group, which lies in the southern part of Singhum Craton. It is formed in an intracratonic basin. As a whole, the Kolan group is a transgressive feature that is interpreted as having formed in a rift setting. So, all this is about the Singhum Craton and its stratigraphic succession and horizon. You are expected to go through the details of it, and if there are any doubts, you can always ask. Thank you.